Hello and welcome to this presentation about data flow diagrams. The intended audience of this presentation is VCE computing students, in particular doing software development in Year 12 but also for Year 11s. So our data flow diagram is an analytical tool, and so we use it in the analysis part of our problem solving methodology. Our learning intention is that students can explain the purpose and conventions of a data flow diagram. Just to recap, our problem-solving methodology has 4 parts: analysis, which is where this diagram belongs; design, which is where I feel like this diagram actually could belong to, but it doesn't; the development stage and the evaluation stage. So what is a data flow diagram? Well, here we can see one, and the first thing I want to say is this doesn't represent the entire application. Whereas our use case diagram does and our context diagram does, this is only representing a handful of functions, or processes, which are represented there by the circles. We have the external entities there, we have a database there, and we have the flows of the data. But let's get into it in a little bit more detail. It is a graphical representation that illustrates how data moves through an information system. It shows the flow of information between different processes, data stores, and external entities. It's an analysis tool, as I said, used in the analysis stage of the problem-solving methodology. I think of it as part of it where we're getting our ducks lined up in terms of what do we need this program to do long before we start writing code. Well, what are the conventions of this diagram? We are using, now I want to say, off the top of my head I can't remember the names, it's somebody DeMarco. We're using their conventions in this. It'll come back to me. Shows data flowing in and out of major processes. Often these will be functions. If you're using OOP, these might be classes and these might be methods within your classes, but getting your ducks lined up like this is a really good way to involve in sort of compartmentalization and modular programming. One of the spaces I read says between 3 and 9 processes per diagram. My personal preference is to have a few more diagrams and break them down, probably not only one process, but I can think of processes that would be quite complicated that it's probably worth actually just having their own diagram for. Pixels are free, but I read 3 to 9, and I think grouping them by purpose is a really good idea. So if we go back to this example back here, this is the user is searching and browsing by categories. So I think of those as quite similar in terms of the function. We're either putting in a search term or we're saying, hey, bring me back, all of the space mollies, and then it's bringing them back according to that. So I think there's a lot to be said for grouping them by purpose. Now, what else? Use cases will be represented between all of your DFTs. What am I saying there? So all of the use cases that you have in your use case diagram, all of them will be represented between all of your data flow diagrams. So you'll actually go out and map the data that's necessary to support all of those user functions or all of those active functions. So this is part of what we call traceability. So when we talk about traceability, what we mean is that we can actually go from our use case diagram and say, okay, now that we know what it is that people are doing, well, what data is going to be flowing in and out of the system from these entities, and we should be able to match everything that's in here back to there. Now, some of these things will be assumptions and won't necessarily tie straight, they won't be explicit over here, such as accessing the API, but we can still say, well, we're doing that in support of search figures or add figures. So when we say traceability, I mean we can draw a line back and say, this came from there. So we can go from our use case diagram to our context diagram, and likewise we should be going from our context diagram over to individual data flow diagrams. So what I've got here is log in and create account, and this is actually these two, or these pair of pairs of processes there are represented in more detail. There's a higher level of abstraction over here, whereas it's pretty explicit over here. So the components of this, well, we have the processes. A process transforms or manipulates data. One of the rules of these diagrams is you can't go straight from an entity to a database. You have to have a process in between. So for instance, the user is going to put in the search term, and this process here is going to transform that into a query that it's going to hit the database with. Typically, these are drawn as a circle or a rounded rectangle, and the name should be kept short. So you say search items, create list. I've actually seen it said that it should be a verb followed by a noun, such as search items, browse by category, create list, view item. I don't think you have to be quite that rigid, but I have seen it suggested. And each process should have at least one input and one output. So information, even if it's just going in there to be stored, then you want to have a confirmation coming back, say, yes, it was successfully stored. And each process should transform data and not just transport it. So if the user's literally giving you a search term, then that could go straight through there, but then that would violate the rule of entities interacting with databases. But they are about transforming, even if that transformation is minor or subtle. So with the data store, there are different ways. To do it, but in this particular set of conventions, it's represented by two horizontal lines, and that there is a database called figures, or a data store. It's the location where the data is held. It might be temporary, it might be permanent. They call it an open rectangle. Yeah, all right. And it should have at least one input and one output. So as you can see, I've got some inputs coming in here. A bit of a typo there from me. That is not how you spell category. A data flow is just the arrows, and it says what the name of the data is that's being moved. So it indicates movement with labels describing the data, so not the purpose of it, but what data is being handed across. So for instance here, the user is handing across the category name. They're handing back a formatted list. So it's not about what you're doing, it's about what you're handing across. And the external entities are sources or destination, and they're drawn as a rectangle, and you can see the user there. So let's have a quick look at what we know. So what do two parallel horizontal lines represent? I guess horizontal lines are definitionally parallel. Well, that's a data store. A data store doesn't have to be a database, by the way. It could be a CSV file. It could be a text file. I think in most cases it's going to be a database, but data store doesn't necessarily mean database. What does a circle represent? Well, that represents a process, and in lots of cases that process will be inside a method or a function. What does a rectangle represent? Well, that represents an entity. Now that could be a person or it could be another system. And what does an arrow represent? Well, that represents data flowing from one place to another, and it will have a label on it saying what that data is. And finally, what does a line without an arrow represent? Well, that's a trick question. An arrow without a line doesn't have a place in a data flow diagram. So that's the end of that presentation, and I hope it's been useful to you.